assignment, but before that, I want to continue on the discussion about component algebra of vectors, which is what we were discussing last time. So, taking a quick recap about component representation of vectors. This is where we left off in the last lecture. So we saw that in a two-dimensional system, a vector is notated or it is represented in the form of an equation like this, where we saw that Ex and Ey are scalars quantities, but I cap and J cap are what are called unit vectors. So I cap was the unit vector along positive x-axis. The unit vector fact means that its magnitude equals to 1. The mod is 1. Whereas its direction is along the positive x-axis. Similarly, J cap is defined as the unit vector along positive y-axis. And Ax and Ay are respectively called the x component of the vector E and the y component of the vector E, and they are both scalars. They are scalars which can be positive or negative. So this was the representation itself, which we seen in the last lecture. Now we just continue with understanding this representation with more examples before we can do algebra using this kind of notation. So, for example, we have a situation like this. We want to draw the following vectors in the xy plane. The vector E is suppose 2 I cap plus 2 3 J cap. The vector B is minus 3 I cap plus 4 J cap. And the vector C is 5 J cap. So how will we draw these vectors? So let's understand them one by one. So first of all, we will have to define our coordinate plane. So we will define in general default manner, we always define the vertical direction as our y-axis and the horizontal as our x-axis. Or you can even think of it like this, that the north direction is our y-axis and the east direction is our x-axis, like this. Whatever. Once we've defined this, now we are given the vector E. In the question, it was given to us as 2 I cap plus 2 root 3 J cap. We have to understand that 2 I cap would be a vector, it would be like this. Let's say like this, of magnitude 2 units along the x-axis. This is what 2 I cap would be. Similarly, 2 J cap would be a vector like this. So 2 3 J cap would be a vector pointing along the y-axis, but its magnitude is how much? 2 root 3. This would be the vector 2 root 3 J cap. So A vector, which is the sum of this and this, would become which vector now? The A vector would become this one, the sum of these two. This is the vector P. This vector in our diagram will represent E. And Similarly, suppose the vector b was given to us as minus 3 I cap plus 4 j cap. In comparison, minus 3 I cap would be along the negative x-axis because it's minus 3 times I cap. So that would look like this. I'm not drawing to exact scale, okay, but this is minus 3 I cap and 4 j cap. We from here draw a vertical vector of magnitude 4 units. That would be this, okay. So vector b, which is the sum of these two, minus 3 I cap plus 4 j cap, that would become this vector. This vector will become the vector b. Because it has an x component which is along the negative x direction of minus 3 and a y component along the positive direction. And you can see the third vector, it was 5 j cap, or let's just make it, just to make the diagram easier to draw. Let me make this minus 5 j cap. The vector c now is minus 5 j cap. So it doesn't have an x component. Its direction is purely along the negative y-axis, and it would simply be this vector. Minus 5 j cap. This would be the vectors. So just make a note of this example and see if everything is clear to you. Just give you some time to take down the vectors first, which are given above. Then you can take down the diagram. Just take down the question and take down the diagram, it will be automatically clear to you. Just take down the question, Itanshu. The question is written in plain language. Draw the following vectors. Yes, it can be drawn. Kunal, I'll answer your question. Okay. Just give me a moment, I'll answer your question. So yeah, so see, Kunal, to answer your question, any vector can be drawn from anywhere. SNE, we have to draw it from the origin. Suppose I wanted to draw the vector b from this point. How would I draw the vector b from this point? So the vector b is minus 3 I cap. So from here, I would draw an arrow of minus 3 along the x-axis and plus 4 j cap. So plus 4 along the y-axis. So it's like this. So then this would become my vector b. It would be like this. So here vector b would be like this. Or I could draw vector b here also. Or I could draw vector b. But as long as, so it can be drawn in any of the 4 quadrants from any point. It can be drawn from this point also. Chalega, there's no problem. But the important thing is that it should have this component equal to minus 3 I cap. And this component, the same as this one, as plus 4 j cap. So that is becoming the vector. It is the sum of minus 3 I cap plus 4 j cap. right? And similarly, the vector C I can draw anywhere, but it should be just such that its direction is along the negative y-axis. So it's minus 5j cap. C could be drawn anywhere. So it is just for reference that we have drawn them all from the origin. Okay. In principle, they can be drawn. That is the important thing. Yes. Hitanshul, can you tell me what is your doubt now? Yeah, in vector C, see what is happening. There is no x component. Okay, so hey, na? So you can interpret this as 0 I cap minus 5 j cap. So the x component of the vector C is 0 and the y component is minus 5. So that is why the vector is lying purely along the negative y-axis. Yes, I just answered that question. Okay. We can draw the vector anywhere. We can draw the vector B from here also. But if we are drawing it from here, it's going to have a negative x component and a positive y component. So the vector B would look like this. I have not drawn this to scale with this, but it would be like this. You can understand the thing. Okay. Okay, so like this, we can draw any vector whose components are known to us. We can draw any vector whose components are known to us like this. Now, the other thing we saw is that once we know the components, how do we know the magnitude and the angle of the vector? So the next thing we saw that in general, if we know the vector in terms of its component notation, that means for the given vector E, Ax and Ay are known. Okay, so if this is a known quantity, then how do we find the magnitude of the vector E and the angle it is making with respect to the x-axis? Okay. If I take, by default, I take a vector, जिसके दोनों components positive है. So by default, I am taking a vector E whose both components are positive. So that vector E would be such that when I drop a perpendicular from this onto the x-axis, this line it will be cutting, it will be of length Ax. It's along the positive x-axis, so this is the x-axis. Similarly, this one is A by j cap, so that I can also express by cutting a perpendicular here onto the y-axis. So you can see that this over here is the y component, E by j cap. And now if you concentrate on this triangle, this is the angle theta. This is Ay in length. This is Ax in length. So what about magnitude of E? We saw that magnitude of the vector is the hypotenuse of a right angle triangle, जिसका कि base कितना है Ax है और perpendicular कितना है Ey. So this is the formula for the magnitude. And as you can see in that right angle triangle, this is also 90 degrees, this is also 90 degrees. So as you can see in this right angle triangle, tan theta is equal to Ay by Ax. So theta becomes tan inverse of Ay by Ax. So this is just, I've taken an example in the first quadrant, but now we will also speak about trigonometry in the 4 quadrants using this, and you'll understand this. Now, for example, what happened, Itanju? Okay. देखो मैग्नीट्यूड का पार्ट बेटा ऐसा है कि if the vector E is like this, then drop a perpendicular onto the x-axis. This part is AX, and drop a perpendicular onto the y-axis. So this part, which is the same thing as this part here, that is your EY. So see, now it's becoming a right angle triangle. This is becoming a right angle triangle. So this is the magnitude of the vector. No, it's the hypotenuse. So hypotenuse कितना हो जाएगा? It will be square root of base square plus perpendicular square. And यहाँ पे tan theta कितना हो जाएगा? It will be perpendicular upon base. Okay, understood, Sana and Hitanshul? Is it clear now, Sana? Okay. So let's see a quick example using this now. So one thing we have to understand here is that the system of quadrants. For example, if I'm comparing some different vectors like this one, then let's say this one, then this one. So if you talk about their different angles, you will see that if a vector has x component negative and y component positive, example, the vector E in this diagram. Yeah, it can be done geometrically, no problem. Okay. Then its theta is in second quadrant. Okay, that is theta is greater than 90, less than 1. On the other hand, for this other vector B, you can see over here, theta would be like this. Okay. So if the vector has x component negative and y component also negative, यहाँ पे you can see B's y component is also negative, x component is also negative. Okay. Then, so for example, the vector B as shown in the diagram. Then what is happening? Theta is in third quadrant, and that means it is greater than 180 but less than 270 degrees. And on the other hand, for a vector like this one, so this vector D, theta would be like this. So if x is positive, x component is positive and y is negative, that means theta is in fourth quadrant. Okay. Or theta is greater than 270, less than 360. Okay. But you can also express it as a negative quantity. Okay. So for example, or theta is negative of 360 minus. Okay. So for example, theta equal to 330 degrees can also be expressed as theta equal to minus 30 degrees, because we take anti-clockwise as positive and clockwise as negative. So this is the sign convention that we use. Okay. So just make a note of this point over here, and then we will move on to first quadrant. Is obvious. I made the diagram above, so no need to write down everything. But for second, third, and fourth quadrant, you need to understand this. So whenever a vector has x component negative and y component positive, that means this angle is lying in the second quadrant. Whenever both components are negative, that means this angle is lying in the third quadrant with respect to the x-axis. And whenever the x component is positive, whereas the y component is negative, that means this angle is lying in the fourth quadrant. Of course, in each case, the magnitude is given by the same formula. As far as the magnitude is concerned, mod A will be nothing but root of ax square plus ay square. We are squaring the this thing component, so it doesn't matter whether they are negative or positive. Magnitude of B is given by the same formula. Magnitude of C is given by the same formula, or whatever, or T or whatever. But their angles accordingly, depending on the algebraic sign of their components. So if both components are positive first quadrant, if x is negative, y is positive second quadrant. If both components are negative, then third quadrant. And finally, if x is positive and y is negative, then fourth quadrant. Okay. So this is something very important and critical. So let us look at a couple of examples and understand this. Next example, find the magnitudes of each of the following vectors and the angle theta of the vector with respect to the positive x-axis. Okay, so do the above part again. Okay. So quadrant 2, quadrant 3, and quadrant 4 is the condition. Okay. To start working on this question, I am giving the vectors. So vector E Yes, Riti, that's correct. Yes, angle is correct. Dipanshu and Riti. For the first one, the angle is correct. Yes, Dipanshu, second one also angle is correct. Okay, correct, Diti. Yes, stage magnitudes are correct. Third one, Hitanshu, your angle is not correct. Okay, so let me just demonstrate two methods of doing this. One is we can draw the vectors geometrically. That can be done in this way. That for example, the vector E given to us as 2 root 3 I cap plus 2 j cap. If we draw the vector physically, it will look like this. The vector E in my diagram would be this one. So you can see that magnitude of A would be square root of 2 root 3 whole square plus 2 square, so that would be 4. And you can see that theta would be tan inverse of this side, which is 2, divided by the base, which is 2 root 3. That's tan inverse of 1 by root 3 in quadrant 1. So that would be 30 degrees. So that becomes solution for vector. Similarly, if I were to geometrically draw the vector B, so vector B was given to us as minus I cap plus root 3 j cap. That vector would look something like this. Minus I cap, the unit vector along the negative x direction, let's say like this, and plus root 3 j cap, the vector of magnitude root 3 along the y-axis. So now our resultant vector would be this one like this. This would be our resultant vector. The x component is minus 1 and the y component is plus root 3. So this angle would be our theta. So to find this angle, we can start by finding this angle. So we can see that in this triangle that we have drawn for B, this vector B, ये वाला साइड कितना है 1 है और ये वाला साइड कितना है √3 और ये एंगल कितना है अल्फा. So magnitude of B becoming root of bx square plus by square, that is square root of 1 square plus √3 square. So that is 2. So the magnitude of the vector is 2. But also you can see in this diagram, tan alpha is √3 by 1. So alpha is tan inverse √3, which is 60 degrees. So coming back here, you can see that theta is equal to 180 degrees minus alpha. Theta is 120 degrees. It was evident because you can see here that B's x component is negative and B's y component is positive. So therefore, theta has to be obtuse. And that is what we are getting finally. Hitanshu, tan is defined in a triangle, na beta itna to aapko aata hai. In a right angle triangle, if this is the perpendicular and this is the base and this is the hypotenuse, then tan theta is defined as perpendicular upon base. Sin theta is defined as perpendicular upon hypotenuse, and cos theta defined as base upon hypotenuse. You know these things from trigonometry. Yeah. Okay. So like that, we'll do the third and the fourth part also. Okay. Yeah, I'll come to that. Yes. Let's just complete the other two also. So the vector C, sorry, the other minus 12 y cap minus 16 j cap. Let's look at that one next. Yes, magnitude is correct. So the x component is minus 12 and the y component is minus 16. Let's say it looks something like this. So the vector itself being the sum of these two will be like this. This will be the vector C. And this will be the angle it is making with the x-axis. So you can see that Cx is minus 12, Cy is minus 16. Therefore, theta is in third quadrant. Okay. So now we can simplify matters for ourselves and we can think of this angle here as alpha and this right angle triangle where this side is 16, this side is 12. So magnitude of the vector C becomes square root of 12 square plus 16 square. You are squaring, so the sign does not matter. So that is 20. But also you can see that tan alpha, that is 180 degrees. So that is tan alpha is equal to 180 degrees. So that is 180 degrees. So now we can simplify matters for ourselves and we can think of this angle here as alpha and this right angle triangle where this side is 16, this side is 12. So magnitude of the vector C becomes square root of 12 square plus 16 square. You are squaring, so the sign does not matter. So that is 20. But also you can see that tan alpha is equal to 16 by 12, or that is 4 by 3. So that means alpha is tan inverse of 4 by 3, which you know is 53 degrees. Therefore, theta is becoming how much? It is becoming 180 degrees plus alpha. So that means that theta is becoming 233 degrees. Okay. Maybe the perpendicular upon hypotenuse is minus 12. Hidanshu, with respect to this angle, see this triangle. This is your alpha. This is 16. This is 12. After getting the alpha, you mean beta? Did you mean after getting alpha or after getting theta? Yeah, alpha देखो मेरा 53 degrees आ गया. So alpha is which angle? It is the angle made by this vector. Alpha is this angle, ना? The angle made by this vector with respect to the negative axis. ये angle alpha है. But मुझे कौन सा angle निकालना है? I need to find the angle with respect to the positive x-axis. So I need to find out this angle. I need to find out this whole angle. So this angle is how much? It is 180 plus alpha. Yes. Because specifically we've been asked to find the angle with respect to positive x-axis. So we have to give the angle with the proper quadrant. It's in the so as we discussed, it's in third quadrant. The angle is in third quadrant, so it has to be greater than 180. This is showing us that this angle here. Okay. This is showing us that theta will be between in that range between 180 and 270. And similarly, we come to the fourth one. It was 2I cap minus 2j cap. Now you can see here that dx is positive and dy is negative. So that means it must be in the fourth quadrant. It means theta must be greater than 270, less than 360. Or we can express it as negative of some angle also. So plus 2I cap and minus 2j cap. Give us a symmetrical vector like this. The magnitude will become 2 root 2. Right. So you can see that this angle is 45 degrees. So theta we can write as, so magnitude of d is 2 root 2 and theta we can write as 315 degrees or minus 45 degrees. Both are equally correct. Yes, that's correct, Hitanshu. Diti, in the angle, it's important. Na? That's why from this sign only we came to know it's in fourth quadrant. If we had ignored the sign, see 45 is not the angle is 360 minus 45. Okay. So if we are, for example, going by a formula based method, you understand what I am saying. When we discuss a formula based method, if we don't want to draw the diagram, अगर मुझे चाहिए यहाँ पे without visualizing the diagram, just by applying formula, I want to see how to calculate the angle. Okay, so if I want to do this by formula based method, it's a little bit more tricky, but I'll tell you. So for example, I'll take the second one, okay, where the vector b was what it was, minus I cap plus root 3 j cap. So I can see that, okay, as far as formula is concerned, what are my formula? That magnitude of the vector b is square root of bx square plus by square, and theta is tan inverse of dy by bx. But when I'm using this formula, I'll have to be mindful of quadrant. Okay, so let's see over here what happens. Bx is minus 1, by is root 3. So magnitude of b, there's no problem. It is just square root of this minus sign, makes no difference whatsoever. Whether we write it or not doesn't make any difference. So we know that this is 2. But it makes a lot of difference in the angle. Okay. And theta is equal to tan inverse of dy by bx. So that is becoming tan inverse of minus 1 by root 3. Now you will recall that tan theta is negative in which quadrants? In second and again in fourth quadrant. Okay. So somehow we have to figure out कि इसमें से कौन सा है. Okay. But here bx is negative and by is positive. So that is giving us the indication that theta is in second quadrant. It's not in fourth quadrant. It's not in fourth quadrant. So now we'll have to say that, okay, theta is equal to tan inverse minus 1 by root 3. So that means tan theta is equal to minus 1 by root 3, and theta is in second quadrant. So it is greater than 90, less than 180. Okay. So in second quadrant, remember the formula that tan theta is minus of tan 180 minus theta. Okay. So that means tan of 180 minus theta is 1 by root 3. So that means, oh sorry, it was ulta, I think. It was root 3. Because the y component was root 3, the x component was minus 1. So you just make a correction here. Just excuse me while I do that. Okay. So this is root 3. So that is telling me that 180 minus theta is 60 degrees. So that is finally telling me that theta is how much is okay. It's 120 degrees. Okay, so this is the formula that I have to use for second quadrant. This is the tan theta formula for theta being greater than 90, less than 1. So this is where this becomes a little complicated. Now, once you get used to it, it's not so complicated, but it's much easier to just visualize the problem. Okay. And if you now just connect this solution to the geometrical solution we've done before, you'll understand we're doing one and the same thing. कोई difference नहीं है. It's just that वहाँ पे we are understanding it geometrically. Here we are understanding it in terms of formula for second quadrant. Okay, so try the third part of the question also by formula based method. Write this down and then yourself you try the third part of the question by formula based method. And just write down the third part. It was minus 12 I cap minus 16 j cap. Yes, Kunal, tell me, Beta, what is your doubt? Just a second. Kunal, can you send your doubt again? I've not received it for some reason. That is a formula from trigonometry, beta. आप trigonometry in 4 quadrants में पढ़ोगे वो formula. That tan of 180 minus theta is minus tan theta. I think you must have done in trigonometry so far, you know. वो ESTC rule पढ़ा है ना अपने trigonometry में तेज. हाँ तो ESTC rule में यही formula आता है ना. Second quadrant में tan कैसे आता है? How do we calculate, for example, tan of 120? It becomes minus tan 60, ना? Oh, Kunal, that question. No. The arrow above the vector symbol has to be drawn that way only. That is like a convention for symbol. It has to be drawn only from left to right. वो arrow का direction का कोई significance नहीं बेटा. That is just to show that it is the vector symbol. So we should not change the direction of the standard notation. Okay, it has to be the way it is written in standard notation. That is from left to right. In many old type of publications of books, you will see in that era, you know, when these symbols were not available in print, so you know, unless people wrote the symbols by hand, the symbols were not available for print. So in that time, vectors in books were symbolized by using bold letters. So कोई भी variable को अगर हम bold letter से लिखते हैं, then it is assumed we think it's a vector, and if we write it with a normal letter, then it's a scalar. But that is very outdated. So nowadays, you know, with computer graphics and all that, all books come with standard maths type text, where the vector symbol used is the same as we are using over here. Cap for unit vector and the arrow for the standard vector. But if you read books from 10 years back or something, you will find NCERT maybe arrow hai beta, koi problem. But if you read books from very old, like 10, 12 years back and all that, you will see that sometimes the vector notation is not there in print. Instead, they use bold letters for vectors and standard letters for scalars. Okay, I'm coming to part 4, Shishir, but let's also discuss part 3 by the formula based method. Okay. So yeah, coming back to this, Kunal, the two standard notations is arrow like this, it always stands for vector, any general vector. Whereas if the arrow is replaced with a cap, it means it's a unit vector. In fact, we'll be discussing more about unit vectors today also. Okay. Now this one, let us understand formula based. So x component is minus 12, y component is minus 16. That means theta is in third quadrant. Theta is greater than 180, less than 270. Okay. So for this, we will use the formula that tan theta is equal to positive of tan 180 plus or theta minus 180. So for example, tan of 210 degrees is the same as tan 30, which is positive of 1 by root 3. So this formula we'll use, the quadrant 4 formula over here. So anyway, coming back here, magnitude of C, so no problem, it just becomes so that's 20. But we can also see that tan theta is minus 16 by minus 12. So that is 4 by 3. But theta is in quadrant 3. So we have to understand that tan theta will be the same as tan of theta minus 180, which is 4 pi. So theta minus 180 degrees is tan inverse 4 by 3, or theta minus 180 degrees is 53 degrees. So theta is equal to 180 plus 53, or 232. So again, it becomes a complicated process. It is basically the maths trigonometric equation type of method of solving. So it is complicated. So that is why just visualizing the diagram is much easier way of solving this kind of thing. Just make a note of this, guys, and you can try out the fourth part yourself also. You will get it quite easily. Okay, so now Again, for the fourth one, what we'll have to understand is the x component is positive and the y component is negative. So x component is positive, y component is negative. This is showing you that theta is in quadrant 4. So remember, what is the formula for quadrant 4? That tan theta is equal to minus of tan 360 minus theta. So for example, tan of 315 is minus tan 45 is minus 1. So this type of formula you have to use. In fact, this is the one we'll be using here exactly. Okay. So magnitude of D. So the sign doesn't matter here whether I put minus 2 because it's a whole square. So that's 2 root 2. So that's fine. But tan theta will become minus 1. So theta is equal to tan inverse of minus 1 in quadrant 4. So in quadrant 4, this means that tan of theta is minus of tan 360 minus theta is minus 1. So that means tan of 360 minus theta is 1. So that further means that 360 minus theta is 45 degrees. So that means theta must be 360 minus 45. In B part, it is 120 degrees. It is not minus 60. Minus 60 वो angle नहीं होता बेटा. Minus 60 ये angle होता है. With respect to xy coordinate, something which is at 120 degrees will look like this. This angle is 120. Okay. And something which is at minus 60 will look like this. This angle is theta equal to minus 60 degrees, which is the same thing as 300 degrees. They are different things. So it's always clockwise, anti-clockwise with respect to positive x-axis. So anti-clockwise with respect to positive x-axis is taken with positive sign, and clockwise with respect to positive x-axis is taken with negative sign. So that is our sign convention for the angles in standard trigonometry as well as vector algebra. Okay, so I think this must be clear to all of you by now. Okay, so we will just do a bit more practice in this with a very simple question now. Very interesting, simple type of question. So next example, I want you to find the angle between the vectors A and B. Okay. Given that the vector A is 12i cap plus 16j cap and the vector B is minus 8i cap plus 6j cap. Find the angle between the two vectors. Just try this out. Just think any method that comes to mind for you for solving this. It's related to what we've just been discussing right now. right? So if we were to draw the vector E, this is what it would look like, because the vector E is given to us as 12 y cap plus 16 j cap. So it would be at an angle of 53 degrees with respect to the x-axis in our standard xy plane. Now similarly, if we want to draw the vector B, how would that look like? So the vector B was given to us as minus 8 I cap plus 6 j cap. So that vector B would look something like this. Minus 8 I cap plus 6 j cap. So that would mean that drop a perpendicular here. This side would be 8, but on the negative side, and this side would be 6, the positive side. So minus 8 I cap plus 6 j cap. So we can see that if this angle is beta, we can see that beta is tan inverse of 6 by 8, or it is 37 degrees. So now we have to find this angle between the two of them. This is the angle we are looking to find. So that theta would be just 180 degrees minus alpha plus beta. And that would come out to be 90 degrees. So that is correct. Theta equal to 90 degrees is the correct. So this is the easiest way to understand this question. Okay, so hope this is clear, people. The next part of our study here is the reverse of what we've done in these type of questions. That we were given the components and we found out the magnitude and angle. Now the reverse of that, given the magnitude of a vector and the angle, given the magnitude of the vector and the angle theta with respect to positive x-axis, how do we find Ax and Ay? It's very simple. Given the magnitude, that means we know the hypotenuse of this triangle. So this is the vector E. The hypotenuse is the magnitude, and this angle is theta. So you can see that the x component and the y component, it doesn't matter whether we draw it here or we draw it here. You can see that right angle triangle is such that this is Ax, this is Ay, this is magnitude of E, and this angle is theta. So you can see that Ax becomes E cos theta, Ey becomes E sin theta. And from here, you can also understand that this is the general formula, but you can also understand what happens in the different quadrants. So we'll come to that, but write this down first. So these are the formulae by which we calculate Ax and Ay provided we know the magnitude of the vector and the angle it is making with the x-axis. So the x component is a cos theta, the y component is a sin theta. Yeah, these are the formulae that we use to find out these two things, ax and ay, provided we are given these two things, magnitude of a and angle theta. So let's understand each of the quadrants with an example each. Okay. Now, for example, if I have a vector b, which is given as such that the magnitude of that vector is 20 and the angle is 150 degrees with respect to x-axis. Now I say find dx and dy and express the vector b in component form. Okay. So one is I can understand this geometrically. I can first draw the vector, and from that I can understand this geometrically, that if I were to draw an xy plane, then in this diagram my vector b would have to be over here. It's making an angle of 150 degrees, so it would have to be like this. Something like this would have to be my vector b, with this angle being 150, okay, and its magnitude being 20 units. So now if I want to find the components using geometry, what I would do is, in this diagram, I would simply drop a perpendicular here, and I drop perpendicular here. Now in this triangle, I would see that this angle is 30 degrees. Okay. So what would this become? This would become, this is the base, let's say, and this is the perpendicular. So the base would become the hypotenuse multiplied by cos 30. And the hypotenuse is how much? It is 20. Okay. So the base would become 10 root 3. Okay. Hence, what about my x component? It would be minus 10 root 3, because you can see that it's pointing along the negative x direction. Now remember, the component is with sign. Okay. So the component would be actually this one. So this would be my bx I cap. Now you can see it's pointing along the negative x direction. So you have to understand that bx is a negative quantity here. So my bx would be minus of that base. And similarly, my perpendicular would be equal to the hypotenuse into sine 30. So that would be 20 into half. So that would be 10. But that means that my y component is pointing along the positive direction. So by j cap has to be such that dy is positive. So that means my y component would be how much? It would be plus 10. And the vector b would be expressed as minus 10 root 3 I cap plus 10. This would be the proper for this vector, which has this geometry. This is the simplest way to understand how this particular vector is having these particular components. from the given information that the vector B was at 150 degrees with respect to the x-axis and its magnitude was 20. This is how we understood that its components are minus 10 root 3 and plus 10 respectively. And these components will be the same units as the magnitude of the vector. So if it's a displacement in meters, then these are also in meters. If it's a force in newtons, then these are also in newtons. Okay. So the algebraic sign is clear to all of you. Why the x component is negative and the y component is positive. Okay. Now you can also go with the formula based method. This was the geometrical method. Now you can also solve this by formula. So we just want to apply formula to see that magnitude of B was 20 and theta was 150. So just apply your ASTC rules. In fact, you will understand that the logic of ASTC rules can be understood very easily from the vector diagram. Now, y is cos 150 minus cos 30. You can understand that from this diagram actually. The correlation between this diagram and the formula. So Bx will be written as B cos theta. So that is 20 cos 150 degrees. Now use the formula for second quadrant. That is cos theta is minus cos 180 minus theta. So cos 150 degrees is minus cos 30 is minus root 3 pi. So using this formula, now my Bx becomes how much? Becomes 20 into minus root 3 by 2. So it becomes minus 10. This is the same that you got here. And using the similar formula, By is B sine theta, which is 20 sine 150. Now again, the formula for quadrant 2 is that sine theta is positive of sine 180 minus theta. ASTC, so sine is positive. So that implies that sine 150 is positive of sine 30 is positive of half. So therefore, your y component becomes 20 into positive of half. So it's plus 10. So again, you can see that agrees with this, and your vector B will be expressed as minus 10 root 3 I cap plus 10 j cap. So in many ways, this vector component concept actually justifies your ASTC rule in trigonometry. So just make a note of this, people. Very important here. Okay, people, so I hope you understood it by trigonometry formula also as well as this. In fact, this is how the formula comes in trigonometry. क्यों होता है ऐसा that cos 150 is minus cos 30? Because if you rotate a vector by 150 degrees, its x component becomes negative. Whereas its y component remains positive. So actually the logic of that ASPC rule and the trigonometric formula are actually coming from the concepts of components of vectors for various different angles in the 4 quadrants. So as a simple logic to understand this, for example, if I were to compare this case where my vector, what was it over here, vector B. So my vector B had a magnitude of 20 and was at theta equal to 150 degrees. Now compare this with another one where vector C is of same magnitude, but the angle it is making is 210 degrees with respect to x-axis. So you see that there's a very nice symmetry between the two. Just a second, guys. Yeah. So just understand there's a very nice symmetry between the two. If the vector B is like this, 150 degrees means somewhere like this, one we just drew. The corresponding vector C which I have shown over here will be like this one. ऐसा symmetrical हो जाएगा. It's a vector of the same length. So the magnitude is again 20, but this time this angle is how much? It is 210 degrees. So notice that 210 can be written as 180 plus 30, whereas there 150 could be written as 180 minus 30. So you can see that this angle here is equal to this angle here. So that is why both of them share a common x component, but their y components are becoming reverse of each other. So this, when you draw this base, it will be 10 root 3, whereas this will be 10, this will be 10, but they will come with minus sign when you write them as components. So that is why you can see that the vector B we had already written before. In case of vector B, we had minus 10 root 3 I cap plus 10 j cap. So you already seen. In the case of vector C, ये क्या हो जाएगा? मेरा C का x component जो है will be 20 cos 210. So it will become 20 into minus cos 50. So it will become minus 10. And C's y component will be 20 sin 210. So this will become 20 into minus sin 30. So that will become minus 10. So this will become minus 10 root 3 I cap minus 10 j cap. So from here you can see the comparison of the formulae for second quadrant and third quadrant. You can see the comparison. For second quadrant, you have the formula that cos of theta minus 180 is minus cos theta, and sine of theta minus 180 is positive sine theta. Whereas for the quadrant 3, You have the formula that cos of, sorry, my mistake here, this is 180 minus theta. Just make a correction. Second quadrant may we write it as 180 minus theta. Third quadrant may we write it as theta minus 180. So sine of theta minus 180. The diagram. Hope this is clear, people. Yes, you have doubt, but okay, I will just check. Yeah, I think there was temporary drop in my net speed. Now it's okay. Yeah, so Tej, what I was saying is that by looking at this example, yeah, it's okay. By looking at this example, you can understand that the logic between this formula. In second quadrant, the formula is we write cos 180 minus theta is minus cos theta and cos sine 180 minus theta is plus sine theta. Because in this example, you can see, for example, 150 is 180 minus 30. So that's why your cos 150 becomes minus cos 30 and your sine 150 becomes plus sine 30. So that's how we got these components earlier. But same thing if you now take it to the third quadrant, like 210 is 180 plus 30. So what happens is both next component, one is a positive icon in the diagram. If you just compare the two right angle triangles that you're getting, 30-degree one and 30-degree one here, Okay, so I have switched network. Okay, so should be better now. Yeah, so it will be. Students, are you able to hear me now clearly? Yes, is the audio all right now? Okay, right. So yeah, the video will lag a little bit because I'm now on a different network. I'm on 4G network actually. So, but I think the audio should be fine. Okay, don't worry. Audio should be fine. Plus, I'm recording it, so you will get the recording later. Yeah. Now coming back to this, as I was saying, now if you compare the two vectors in this example that I've taken, you compare the two vectors B and C. दोनों का magnitude same है 20 and 20, but their angles are kind of symmetric. One is at 150 degrees, so that one is in the third quadrant, such that this angle is 150. So the angle with the negative x-axis is 30 degrees, but it's in the second quadrant. And the third vector, I mean the other vector, is at an angle of 210 degrees. So that means it's in the third quadrant, and you can see that the angle is symmetric, because this one is 30 above, this one is 30 below. So just from the geometry of these two triangles, if you look at the geometry of this triangle here, this right angle triangle and this other right angle triangle, they are congruent triangles. You can see they're both 30, 60, 90 congruent triangles with hypotenuse of 20. So you realize that dono vector B and C, they're having the same x component, which is minus 10 root 3 I cap. But their y components are equal and opposite. Now, this one is having a y component. The vector B is having a y component which is positive, and the vector C is having a y component which is negative. So this one is plus 10 j cap and this one is minus 10 j cap. So if you correlate this with the formulae, you understand how the formula makes sense. Why in second quadrant the formula is this way, that cos is negative and sine is positive. Whereas in the third quadrant, both the cos and sine become negative. And this becomes a logic. Okay. So if you correlate the geometry of these two right angle triangles with the components, okay, and you correlate it with the formula that x component is magnitude into cos theta and y component is magnitude into sine theta, then these two formulae, they make a lot of sense. It's almost like a derivation of these two formulae. Yeah, we'll discuss this. We'll come to the homework. Okay, but I want to discuss this part in detail before we come to discussion of homework. Okay. So hope this is clear to all of you. Let's do one final example before we move on to. So next example, vector E has a magnitude of 25 units, okay, and is at theta equal to 153 degrees with respect to x-axis. Find Ax, Ey, and draw the vector and express the vector E in component form. that's correct. No, sorry, just you have got them interchanged. Just check your solution once. I think your x and y are interchanged. Yeah, so tell me how much is ax and how much is ay? Just tell me the components. The x component is how much and the y component is how much? Yes, Riti, that's correct. Good. If I go by formula based method, x component is e cos theta. So that is 25 cos 153. So in the formula based method, I'll have to use the second quadrant formula. So this will be minus cos 37. So that will have to be 25 into minus 4 by 5. So minus 20. So ax will become minus 20. Similarly, ey, which is e sin theta, will become 25 sin 153. So that will be 25 into sin 37, which is 4 by 5. Which is 3 by 5. So the y component will become plus 15. So the vector E should be expressed as minus 20 I cap plus 15 j cap. Oh, my mistake. My mistake. People take the angle as 143. I given you the wrong angle by mistake. Take the angle as 143 degrees. Then you will get this. Make a correction here. No, so the angle I show you the calculation. You will not be getting different. Okay, so just correct the angle. Make it 143 instead of 150. Okay. Or you can simply just draw the vector. You will understand it's the same thing. So this is the vector E of magnitude 25, and this angle here is 143 degrees. That means that we can also express this smaller angle here as 37 degrees. So we can see that we write this as the base, and this is the perpendicular, and this is the hypotenuse. The base will be the hypotenuse into cos 37. So that will here become 15, and that will here become 20, and the perpendicular as h sin 37. The hypotenuse is 25 and this is 15. So now I can see that okay, the x component will be negative. Ax I can see will be minus of 20 because it's along the negative y-axis, x-axis, and it's plus 50. So as a vector quantity, this Ex I cap will be like this, and as a vector quantity, this Ey j cap will be like this, and their sum will give you the vector E. So this is the correlation between geometry and that I know, Namita. I know that sine 37 is 3 by 5. It's a factual thing. And cos 37 is 4 by 5. And tan 37 is 3 by 4. Okay. That's a factual thing, tension. जैसे आप 30 और 60 के लिए जानते हैं ना, like that, it's a factual thing. If you revise through my earlier lecture notes, I have made you write down these things, that 3, 4, 5 triangle, the standard values of sine and cos. Okay, now final thing before we move on to points from your assignment and all that is, if you are doing A plus B in component form, so this simply becomes Ax plus Bx, and this simply becomes Ay plus By. So this becomes a formula of how to do addition of vectors in component method. Yeah, I'll slide up, don't worry. And similarly, if we do E minus B in component form, just express E as Ex I cap plus Ay j cap, and B as Px I cap plus By j cap. Now on opening this bracket, if you take I cap common, you have Ex minus Bx, and opening that bracket, you have Ey minus By. So the formula becomes like this. Now not only this, we can do the operation for any number of vectors in XPC. Oh yeah, sorry. Yeah, thanks for pointing that out. That is dy over there. System is dy. So this is how we do addition or subtraction of vectors by component method. Yeah, Tanisha, I'll take you up to the slide before, but just make a note of this first. Yeah, Tanishka, any doubt with this part, beta? Okay, done. Finished. All right. Okay, so now let's come to the next thing. Yeah. So the next thing is we will look at addition and subtraction by component algebra. So of sum and difference by component algebra. So just make a note of these two formulae first, and they're very self-evident. There's nothing difficult about this. This is like in your normal algebra, you would open the brackets, then you would take I cap common, you would take J cap common. So something like that only we've done over here. So for example, if I have the vector E as 12 I cap plus 10 J cap, and I have the vector B as 2 I cap plus 3 j cap. Then the vector E plus V will simply become 12 plus 2, that is 14 I cap, plus 10 plus 3, that is 13 j cap. So this will become 14 I cap plus 13 j cap. That will be A plus B. But similarly, for the same pair now, E minus B, yes, correct. Same pair now, E minus B will become 12 minus 10, sorry, 12 minus 2, and 10 minus 3. Yes, so 10 I cap plus 7 j cap. That's correct. So very simple stuff. So just make a note of the concept and these two examples of E plus B and E minus B for this particular set of vectors. Yeah, it should be 12 minus 2 only. We had made that correction also, but still it. Yeah, just a couple of more things. Now, just one thing we have to be careful about is the algebraic signs. So, for example, if I have a vector E which is 2 I cap minus j cap, let's say, and I have a vector B that is 3 I cap plus 4 j cap. Now, I say calculate A plus B over here. Just tell me how much will be A plus B. Just calculate A plus B. Yes, that's correct. Because when you are substituting, you have to substitute with correct sign. So you can see that Ax is 2, but Ay is minus 1, and Bx is 3, and By is plus 4. So this becomes 2 plus 3 I cap plus of minus 1 plus 4 j cap. So it becomes 5 I cap plus 3 j cap. Okay. It should not be written as 5 I cap plus 5 j cap, because that component has a negative sign. This should be the correct answer. Yeah, we will see in a bit. For example, the next chapter we will do Newton's laws of motion. That is about the practical application of vectors only, in adding forces. Yes, your answer is correct, beta. Okay. And similarly, if we are doing addition of, if we are doing some operation like this, for example, vector E is given to us as 2 I cap plus j cap. Vector B is given as, suppose, 3 I cap minus j cap, and vector C is given as, let's say, 2 j cap. The difference between unit vector and standard vector, see, unit vector, Kunal, stands for any vector of magnitude 1. So A cap is also a unit vector. Okay. C cap is also a unit vector. But I cap, J cap, and later we'll see there's one more, K cap. These are what we call the standard unit vectors. Why they are the standard unit vectors? Because they have specific direction. Okay. This is along x-axis. This is along y-axis. and this is along z-axis. Okay, so that is the difference between the standard unit vectors and any unit vector. We'll come back to this later. Okay. Okay. Now in this question, we want to find a plus b plus c. Okay, and the magnitude of a plus b plus c. Both these things we want to find. Okay. So a plus b plus c क्या हो जाएगा? Just add all their x components. Yes, that's correct. It will be 2 plus 3 plus 0, and the y component will be 1 minus 1 plus 2. So this will become 5 I cap plus 2j cap. So that's correct. Okay. And magnitude is very simple. Now just use the formula. So it will be root of 5 square plus 2 square. So root of 29 will become the answer. Yes. Yes, that's correct. So this is one thing. The next is mod of a plus b plus c has become square root of 5 square plus 2 square. So as all of you got. Okay. So this is about the component algebra applications. Okay. Now we'll just take few minutes more today. We won't be able to probably cover all the doubts, but few of the questions we'll discuss from your assignment, and the remaining ones we'll keep for next time. Okay. Don't worry, we'll discuss all the details, all the doubts eventually. But also this lecture you'll be able to attempt more questions easily, because we've learned a little bit more about application of the dot product method and all that. Okay. So assignment 3, let's just take a few minutes and work out some of the questions. So for example, let's come to question number 1 and 2. Okay. So let me just cover a few questions here, and then after that, any other questions which I did not manage to cover today, but you have some doubt, you can send me a message, I'll help you out. Okay. So even before the next lecture, hopefully you'll be able to make some progress with those questions. So question 1 and 2 are actually both based on the same data. It's very simple. The vector E is given to us as 2i cap plus 2j cap, and the vector B is given to us as, what is it, I cap plus 2j cap. Now we have to find the magnitude of A plus B and the angle made by A plus B with respect to the x-axis. So first of all, we can see that A plus B will become 3i cap plus 4j cap. So therefore, magnitude of A plus B will become 5. It's a familiar one. Okay. And now you'll also understand that this is at theta equal to tan inverse of y component, that is 4 by 3 in quadrant 1. So that is nothing but 53 degrees. Because if you draw the vector, E plus B will now look something like this. E plus B will be such that its x component is 3 and its y component is 4. So you can see that right? So this is clear. Question 3, I think you people can handle. Okay. Question 4 is a question that we've just done today. Let's come to question 5. Question 4 is actually same as one of the examples we've done in class. So you'll be able to do it or try it yourself. Okay. Next, let's come to question number 5. Yes, I'll explain 8th one after that. No, but concept of components we discussed. So most of the questions should be able to do from that. Okay. So it is given to us that in question 5, the force F1 is 12 I cap minus 16 J cap. The force F2 okay. The force F2 is minus 8 I cap plus how much is it? 13 J cap. Now the force F3 we have to find out. So let us say it is some x I cap plus y j cap. We have to find this out such that the resultant of the forces is 0. So F1 plus F2 plus F3 should be 0. So let's just sum up the forces. So F1 plus F2 plus F3 according to this is 12 minus 8 plus x and minus 16 plus 13 plus y. And this should be a null vector. So this is a null vector. That means its both components should be 0. So 12 minus 8 plus x should be 0. And simultaneously, this component, which is minus 16 plus 13 plus y, should also be 0. So this is telling us that x should be equal to minus 4. And this is telling us that y should be equal to plus 3. So the force F3 should be equal to minus 4 I cap plus 3 j cap. Okay. So now the magnitude of the force you can find out because you know the components. You can see that fine. But this is just one convenient way of solving the problem. Like even otherwise, you could have just drawn the vectors and done this question logically. There are ways by which you can do it just by the basic information also. Okay. Right. Next. Now, 8th question is quite tricky. So I give you some hint on how to do it. Okay. And 8th question is going back to geometrical method. It's can be solved by components, but it's not so easy to solve by components. It's easier to solve by geometrical method. So I will just leave you with the explanation of question 8 and you can try and finish off that question yourself. So in question 8, geometrical method. There are two ways of solving vector algebra. One is using geometrical representation and the other is using the component representation. So in question 8, it is given to us that magnitude of vector E is 5 and given to us that vector C is equal to A plus 2B such that C is perpendicular This is one information given to us. Yes, it is also given to us that the vector D is equal to A plus B. Okay. And that is such that magnitude of D is equal to 5, which notice is equal to magnitude of A. Okay. So now we have to find out various things, like we have to find the angle between A and B. We have to find the magnitude of C. We have to find the magnitude of B. These are all the things we have to find out. So the question is that, see, there are two informations given to us about two additions. दो vector addition की information दिया मुझे. एक is the information given about C. And if you think about this triangle, because C is perpendicular, this will give us a right angle triangle. So it's very easy. If we draw the vector triangle, it will give us a right angle triangle. So it's very easy to draw. So that is the first triangle we draw. And the second that is given to us, the second information is about this addition. And in this you can see that these two are equal. So that means it's a isosceles triangle. No, it's at least isosceles. At least two sides are equal. So again, that is easy. So we'll draw that triangle. Okay. And comparing the geometry of the two triangles, we'll be able to find out our unknowns. So let's do like that. Okay. So let us assume that the vector E is this one. Its magnitude is 5. Okay. Now the vector C is perpendicular to this, is given to us in the question. So the vector C is perpendicular. Yeah, good. Na? Done by geometry. Yeah, it's correct. You can use the mean property. But I will solve it here by using vector triangles. So suppose this is my vector C. So its magnitude I don't know, but I know this angle is this. And C is basically what? A plus 2B. So the vector 2B should be this one. This vector should be 2B. So its magnitude also I don't know. This angle theta also I don't know. Okay. So what information we have from this? We have the information that this equation where A is of course equal to 5. And if you look at this, we have cos theta, which is cos of you can write cos theta as minus of cos beta, let's say. The beta is this angle, and that is nothing but minus of E by 2B. This is the second formula that we have. Okay. So this is from that relation that was given, that C is equal to A plus 2B, such that C was perpendicular to E. So we use that information, and we generated two equations. Okay. Now we also have the information that D is equal to A plus B. Okay. And in that the magnitude of D is equal to 5, which was the magnitude of E. So let's see how that information looks in terms of a triangle. So we convert this information now into a vector triangle. We pick up the same vector A as we had over there. But we'll pick up the vector B, which will be half of this. This is 2B, no? So the vector B will be in the same direction. So the same angle, but it's half in length. इसका length यहाँ पे 2b था, इसका length यहाँ पे कितना है b है, उसका half है, but ये angle theta same. So we are adding the vector b to the vector e, which is 5 in length. Okay. So where is the vector d in this diagram? Is the sum of these two. So in this diagram, the vector d should be this one, okay, where this one's magnitude is 5. So here what we can do is we can make use of the isosceles triangle here, but that doesn't help too much. What we'll have to do is we'll have to make use of the parallelogram law. Okay. So we'll make use of the law that magnitude of d is root of a square plus b square plus 2ab cos theta. Okay. So 5 is equal to square root of 25 plus b square plus 2ab. So that will become a is 10. So plus 10b cos theta. Okay. Or we can square both sides of this equation and get rid of the 25. So 25 is equal to 25 plus b square plus 10b cos theta, or b square plus 10b cos theta is equal to 0. That is my third equation. So this equation, and this equation, now I have to solve them. Solve equations 1, 2 and 3. To solve for the 3 unknown quantities. So solve these 3 equations. For the 3 unknown quantities. Can you wait 2 minutes? Please come. Yeah, so solve these 3 for the unknown quantities which are b, c and theta. Okay, because a is known. Remember, a is 5, so it's a known quantity. So in the 3 equations that I've listed out, you have 3 unknown quantities. Capital B, the magnitude of the vector b is unknown. Capital C, the magnitude of the vector c is unknown. And cos theta is unknown. So cos theta se humko theta mil jayega. So this is the method of solving the question. I have not solved the equations yet for you, but you will understand it quite easily from here, and you will be able to solve. Okay. So these are questions 8, 9, and 10, and for 11, 12, etc. we will discuss. But for 11, 12, etc., the hint for you is that write the vectors a, b, and c in question number 11 and 12 and 13. Okay. In fact, 11, 12, 13, and 14, all the 4 questions are based on that same diagram. Please, you can attempt the questions by writing a, b, and c in component form. Okay. So for questions 11 to 14, what you do is resolve the vectors a, b, and c shown in the diagram into component form. Okay. That is, write them in terms of I cap, j cap form. And then just calculate the options. You'll be able to do it quite easily. Yes, I will send the notes, beta. What is there in that? Every time I send the notes stage. Yeah, send the notes on the group. And send the notes and the recording, both the things. Okay. So I think with this hint, you should be able to do question 11 to 14 quite easily. But anyway, we'll discuss in the next lecture. And there will be another assignment also for today's lecture, so you have to do those questions also. Okay, so that's it for today's lecture, people, and please discuss any doubts with me over WhatsApp if required. If any of the questions you have not understood or you're stuck in any of the steps, you can just send me a message. I'll help you out. So that way you can complete that question before the next lecture. Okay, that's it. Make sure to revise the notes of today's lecture. Very important lecture, especially the ASTC rule and trigonometry. Okay, that's it. Thanks, people.